Which transformations can be used to show that triangle ABC and triangle DEF are similar? Now, triangle ABC is larger than triangle DEF, which means there has to be a dilation as a similarity transformation here. And when determining the dilation, I try to make it as simple as possible. And I usually look for horizontal or vertical corresponding segments if I can find them. AB and DE, those two segments, exactly what I'm looking for. So from A to B is 6. From D to E is 3. And that suggests to me there's a dilation of 1/2. So dilation, and I'm thinking the scale factor is 1/2, and I'm just writing that down as a note to myself right now. So let's look at the coordinate notation here and see. So xy will have to go to 1/2 x, 1/2 y. And there might be other transformations needed afterwards, but let's just go ahead and do this first, and then we can, maybe there'd be a translation or something we need to do, but we'll just deal with that later. So A is -4, -4. And if we apply this dilation of 1/2 x, 1/2 y, you just multiply each value by 1/2 or divide by 2, depending on how you look at it. So you'd end up with -2, -2. And that would put you right here, which is actually right on point D. All right, now let's look at point B. Point B is 2, -4. So we're going to apply the dilation of 1/2. And so 2 would end up being 1, and -4 ends up being -2, because we're simply multiplying by 1/2 here. And 1, -2 is right here on point E. Now it's looking like we might only need this one transformation. Let's just go ahead and finish it up. C is -2, 4. And we'll apply the dilation, and -2 times 1/2 is -1. And then 4 times 1/2 is 2. So -1, 2, that puts it right on point F. So that would put the triangle right here. So that's it, just the one transformation. You can see the dilation shows that the triangles are similar. And here is the coordinate notation for that transformation.